Okay, so the professor is throwing 16 darts at pages of business newspaper, and then it looks like they're picking stocks for those. Okay, so the professor's trying to say, hey, it's like nobody can tell what's going to happen the next day. Stock could rise, stock could fall. So it sounds like there's two things. There's a success or a failure. So if there's only two outcomes possible, then you're talking about a proportion, P. Okay? A proportion is like the decimal form of a percentage. In this case, they're analyzing the percentage of successes probably. So like if you had 7 out of 16 successes, then that's your proportion. You could convert that to a decimal. If 7 out of 16 of those randomly picked stocks went up, then they had 7 out of 16 successes. So what shape would you expect this histogram to be and why? Let's see. It's only a sample size of P. We can go through each option. Skewed right because probability of success and failure are not equal. No, we're assuming that they are equal, right? Because if exactly half the stocks go up and half go down, that's the underlying assumption is that P equals 0.5. They have a 50-50 shot with every stock. So this isn't true. The probability of success and failure, we're assuming that they are equal. So that means the same reason that this one isn't true. We'd say that we'd estimate it to be symmetric because the probabilities of success and failure are equal. If it was a probability like of 0.8 that you get a stock right and 0.2 that you get the stock wrong, then you're talking about a skew. Okay, and to figure out which direction that skew is in, you could try out some numbers. So let's say we got 16 stocks, and let's say we're looking at somebody that's actually good at picking stocks. I don't think anyone's this good. 0.8 is the probability of success. When the probability of getting one stock correct is 0.8 to the first power times 0.2 to the 15th power. There's 15 wrong stocks and one correct stock. That's a really low number, right? You can do that with your calculator to figure out exactly what decimal it turns out to be. And if you wanted the probability of getting two stocks right, it'd be this in your calculator. As long as you do the order of operations correctly, these are being multiplied, right? And then once you get up to n equals 15 and n equals 16, then the probability is much higher because the 0.8 probability has a higher power on top of it. The whole reason I'm doing this is to show you that this one would be left skewed, okay? Because you would have a whole bunch of outliers to the left. They're the dots, if you were to graph these in a histogram, this example that I'm graphing will look something like this. And there is something I'm missing here. The combinations for the number of different ways. There's 16 factorial over 2 factorial and then 14 factorial. We usually don't have to concern ourselves with this formula because we use technology for calculating each of these probabilities, but I forgot about the number of different ways for each of those options. But yeah, if you were to go through this is called the binomial distribution. The smallest probabilities are down here. The highest probabilities, that the dots would go up higher on your probability on the y-axis. So this would be left skewed. This one is symmetric because we're assuming half go up and half go down. That means the probability of success isn't 0.8, the probability of success is 0.5. So for that really unlikely scenario that you get every stock wrong, that's a low probability. And the really unlikely scenario that you get every stock correct, that's also a really low probability. But then the probability goes up the closer you get to the 50-50 mark, right? So it would be centered right here at 8 successes. If you have 8 successes, that's the highest chance of happening with a 50-50 stock choice. Okay, so that's why this one is symmetric. All right, let's see what else we got. Where do you expect the histogram to be centered? So this is what we were just talking about. We expect this to be centered at 0.5 for probability, right? Because at 0.5, that's where you have the most possible outcomes, right in the center. In the center is wherever the highest probability is going to happen. For this other example that I did, 0.8 would be the center, okay? Because that's a probability of successes. although it would be skewed, so it wouldn't be a true center. But how much variability would you expect among these proportions? So we can calculate this. And look, this looks like the normal distribution, right? So you might have seen this in the textbook, but to calculate a z-score for a proportion, you'd take your sample proportion, subtract it by the hypothesized proportion, and then divide it by the standard deviation of proportions, which is p times q over n. Okay. So that's how much you'd expect it to spread. The standard deviation of the histogram is what they're saying. So same idea. And then they have exact calculations. Let's see. So this isn't the right formula. This isn't the right formula. The only right formula looks to be this one. And I'm going to assume that they got that correct. I guess we could check it real quick. If we did 0.5 times 0.5, divide by 60, and then take the square root, that should be 0.125. And we can do that real quick. 0.5 is probably a success, and I haven't explained this yet, but I'll tell you in the book, Q is 1 minus P. So 1 minus 0.5 is also 0.5. So if we take a square root, yeah, that checks out. Okay, so that is the standard error of a proportion. So that'd be the standard deviation of the histogram. Explain why a normal model should not be used here. Okay, so at the beginning, the first thing my mind thought is like, we've only got 16 samples. So that's not a lot, okay? You usually have to have something more like 30 or more to assume that it's normally distributed. But let's go through each of these. The success-failure condition is not met. The success-failure condition says that you need to have these two inequalities to be true. And actually, I've seen these be different from one book to the other. N times P needs to be greater than 10, and N times Q needs to be greater than 10. And if those conditions aren't met, then your distribution of numbers isn't going to be approximately normally distributed. There'll be too much fluctuation. So N is 16, right? P is 0.5. If you multiply that, you get 8. 8 is not greater than 10. The success-failure condition is not met. That's true. The 10% condition is not met. That would be if there are... So the 10% condition is basically this. N times 0.10 needs to be greater than N, where capital N is the total population size, the number of possible stocks. And that's like, for America, that's like 4,000 or something. So 4,000 times 0.1 is 400. 400 is definitely greater than our sample size of 16. So the 10% condition is met. Randomized condition, that seems to be met. They're throwing darts at a dartboard. Are they blindfolded? Oh, they're not blindfolded. That's not super random. Because whatever stock is in the center is going to be more likely to be chosen. But maybe if you say every stock is randomly spread out, I don't know. That's kind of a weird one. That's not a proper randomization, so that one's kind of true too. But the success failure definitely isn't met, and we can show that with mathematics, just like what they're saying here, like I said.